Okay, it is time to get started. Thank you everyone for joining our live lecture today. My name is Isaac and I'll be the lead instructor for the lecture. And today's topic will be Programming Foundations in JavaScript Part 2. So what that means is this lecture will cover the second half of the Programming Foundations in JavaScript curriculum. So if you're in that section, this is the lecture for you. A couple things to mention before we get started today. The first one is that we're going to stop periodically throughout this lecture to open the floor for questions. So we just ask if you do have questions come up along the way, you wait until those designated times to ask them. Another thing to mention is that we're recording this lecture. So once we're done here, we're going to post it on our YouTube channel. We're going to make that link available to you in your student dashboard. Okay, so let's go ahead and start off by discussing what topics we're going to be learning about today. And the primary feature for today's lecture will be ES6, okay? And so let's start by talking about what is ES6, okay? So ES6, also known as ES 2015, is the sixth version of the JavaScript programming language, okay? And the point of creating new versions of a programming language is to improve on the older versions, okay? So it's very much like a car, right? Every year there's a new car released for different, models. And so they're trying to improve on the older version. And so we're going to be learning about some of the newer features in ES6 today. Okay, so first one we're going to talk about is a template literal. Okay, and a template literal is a string literal that allows embedded expressions. Okay, so let's go ahead and start off by creating a template literal. To do this, we'll need to set up a base project. So I'm going to go ahead and let's just navigate to our desktop. And on our desktop, I'm going to make a new directory. I'll call it Programming Foundations. And then I'll open up Programming Foundations inside of my text editor. Okay, so we have Programming Foundations open up. Okay, perfect. So now we can go ahead and we can add an HTML doc. I'll call mine index.html. Okay, and then we'll add an HTML skeleton. So I'll just put the main HTML element, and then we'll go ahead and put the head, and then the title. Let's see here. For the title, let's go ahead and let's say Programming Foundations. Okay, and then below the head, let's put a body. Oops, there we go. Okay, and for the body, it's going to be our visible content. So we'll just say something like hello world. Okay, so now we have that set up. Let's go ahead and save all. And let's copy the path of our index. And we'll paste that on in our browser. You can see that it's rendering that content accordingly. Okay, so now we can bring in our script file and we can link it up to our document here. So I'm going to go ahead and I'm going to create an app.js right in my root directory. And then at the bottom of the body, I'll go ahead and link it up. Okay, so I'm going to say app scripts here. And they will be pointing to app.js. Okay, so we can save all. We can open up our network here. And when we refresh, we can see that's loading in our script as well as our document. Okay, so now we can go over to our script and we can create a template literal. Now, the point behind template literals, again, is it allows embedded expressions. And before ES6 came along, we would always have to use concatenation. Okay, so the old approach was like this. If we had a couple variables, let's say we have a name variable, okay, and we'll make that equal to Joe. And maybe we'll have an age variable and we'll make it equal to 99. We want to insert these into a string, we would have to perform concatenation like this. We'd have to say hello plus, and then we would insert the name variable, like let's say my age or name. Then we'd say plus, quotes, comma, your age is, and then plus my age. Okay, so we save this, refresh, you can see that it takes those two variables and embeds them in the string. But you also might notice that this is a very clean code style, right? Because we're using these arithmetic operations just to combine strings. That doesn't make much sense. So instead, we can use a template literal to easily embed these variable values. Okay, so template literal, instead of using the quotes, I'm going to use backticks. Okay, and then I'm going to pass in raw text. So I'll just say hello. My name is, and then to embed the name, I can say bling brackets, and then I'll reference the name of the variable. And that will parse it to a string. And then we can say, and my age is, and then we can do the same approach, right? We can say my age. Okay, so now let's save all, and let's refresh our browser. Okay, as you can see, it takes all those variable values and embeds them within our string here without us having to use any arithmetic operations, right? Anything like that. We just simply insert them and parse them accordingly. Okay, so once again, that's referenced as a template literal. Okay, moving on, let's talk about some new parameters we can use in ES6. Okay, so a default parameter allows parameters to be initialized with default values, and a rest parameter allows a single parameter to represent an indefinite number of arguments as an array. So let's go ahead and create a default parameter and a rest parameter. So can come to our code here, and we'll start with the default parameter. Okay, and let's say we have a store that sells apples. We want to write a little program to calculate the price. So I'll have the quantity of apples declared here, and the quantity will be maybe 10. And then I'll create a function which will be called calculate cost. Okay, and then I'm going to assign this a default parameter of price equal to 2. So now what that allows me to do is I can invoke the calculate cost function. I don't have to pass in any arguments because I've already got a static argument passed in and being represented as a default parameter here. So now I can get the total by saying let total equals quantity times price. And then we can console log the value of total. So we save all, and we go back to our browser and refresh. You can see we're getting the value of 20. And that's because 10 apples at a default value of $2 each is going to be 10. Okay? And this is how we can set up default parameters. Now, a rest parameter is where we can pass in as many arguments as we want and represent all of them with a single parameter. Okay, so let's say we have several different factors included in our sale. Okay, so let's say we have the quantity of apples. Maybe we'll say that's 7. Then we'll have maybe the price of the apples. Okay, and let's say that's 2. And then maybe we'd have tax, which would be 1. Okay, so to set up the calculate cost function, we'll just say function calculate cost. And then when we go to invoke the calculate cost function, we'll pass in the quantity, the price, and the tax all as the arguments. And now I can represent all these arguments with a single rest parameter. And how I do that is I say dot, 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 and I put the name of the parameter, which in my case I'm going to call factors. Okay, so now I have the factors of the sale. I can just use simple index positioning to get their values. So I'm going to start off by creating a total, which will be equal to quantity times price. Because quantity is at the index of 0, we can simply say factors at the index of 0. And then because price is at the index of 1, we can say factors at the index of 1. Okay, so now we got that set up. From here, we can add the tax. So I could say let subtotal equals total plus factors at the index of 2. As you can see, I'm just referencing, their various position as they were passed in. So now we can go ahead and we can console log the value of subtotal. So we save all, and we refresh. We can see that we're getting $15, right? Because they got 7 apples at $2 each is $14 plus $1 tax. Okay, and yeah, as you can see, it doesn't really care how many parameter values or arguments we pass in. We can always just represent all those with a single rest parameter. Okay. So, moving right along, another great feature that came with ES6 is known as the arrow function. Okay, so an arrow function is a shorthand version of a function expression. So let's go ahead and let's create an arrow function. Okay, so let's say we want a function that will greet someone, right? You'll take in a name and greet them. So to do this, we could say let greeting equals function, and then we could console log the name of the person. Okay, so down here we could say greeting, and we could say Joe, which would take in the parameter of name, and we could console log hello. Okay, so as we can see here, this is just a regular function expression, right? And when I refresh it, it gives me the expected result, a console log. But now we can shorten this and compress it even more by using an arrow function. Okay, so an arrow function works like this. Instead of using the word function, we're going to use an arrow. Okay, and as you can see, this is much shorter than our traditional approach to creating a function expression. So let's go ahead and save all. Let's refresh. Okay, and as you can see, we get the same exact result, right? Except this time, we're using much less code, right? We don't have to say the big old long word function every time we want to create a function expression, okay? And so this, again, is what's known as an arrow function. And it will return whatever block of code that precedes it. So let's go ahead and let's move on to the topic of ES6 classes. Okay, so a class is a blueprint that can be used to create new object instances. Okay, and on a class, we've got various different characteristics. One is called a method, and it's a function that's stored in a class. Another thing is called a constructor, and that's a method on the class that's immediately invoked. Then we've got getters and setters methods, which we can use to read and write values of a class. So, as well as these built-in methods, we also have the ability to inherit class values from each other, right? So one class known as a base class can lend its characteristics to the other. We can use these words extends and super to access and reference those base class values. Okay, so let's go ahead and take a moment to create a class, and let's play around with how we get and set values, and also how we would set up inheritance and all that good stuff. Okay, so let's go ahead and first start off by creating a simple store, and the store will just have different products with a price and name. Okay, and so if we were to do this before ES6, it would look something similar to this. We'd create an object literal for each piece of data. So we would say let product 1 equals, and then we'd have a name for the product, and then we'd have a price. Okay, and then we could go ahead and create more products. Okay, so as you can see, I'm only 3 products in here, but this is really repetitive already, right? Because pretty much the only difference between all my products is the values I pass in, but the overall structure of the product's the same. So to avoid this, I can use a class to create a single blueprint and just create new instances from that. So what I'm going to do is I'll erase my previous products, and I'll create a new product class. How I'm going to do that is I'll use the class keyword, follow up with the name of the class. The name of the class always needs to be uppercase. And I know that a little different because most things in JavaScript are camel case, but classes are one of those exceptions to the rule. Okay, so we create a product class, and now this is going to need to represent a blueprint of an actual object. So what we need to do is we need to have a setter method to where we can set values on this class and assign it. So I'm going to go ahead and I'm going to say set, I'll say name of the product, we'll pass in a value, and then we will reference the product class with this keyword, and we will create an underscore name property and make it equal to the value passed in. Okay, and now we'll set a getter for name, And this is going to return this dot underscore name, just like we set here. So now we'll do the setter for price. We'll pass it a value, and then we will return this dot underscore price equals that value. And finally, we can set up a getter for price, which time it will simply return this dot underscore price. Okay, so now we can create what's called a new object instance. And how we do this is we'll declare a variable. I'll call it product1. I'll make it equal to a new product. Okay, so now this variable is an object which has all these characteristics. Okay, so now I can set a name and a price on it. How I'm going to do that is I'll say product1.name equals apples. And then I'll say product1.price equals $2.99. So now we just create a new object instance. Let's go ahead and console log that to our browser. So save all. Go back to our browser. We refresh. We can see that we get a brand new object created, right? As an underscore name and an underscore price property, just like we set up in our blueprint here. And then when we actually initialize that, we assigned it and set the values. Okay? So now let's go ahead and let's explore how we can work with the class's constructor. Okay? So just like we have these built-in getters and setters methods, we also have a built-in method called a constructor. And the job of the constructor is a method that immediately runs as soon as this class is instantiated, okay? And so that being said, we can use it to initialize values on this class before it's even, set. So what I'm gonna do is I'm gonna say this dot name equals, we'll say grapes, okay? And then I'll say this dot price equals 99 cents. Okay, and so now what we can do is we can create a new instance of the product. So I'll say let product1 equals new product. And from here, we don't have to set any values, right? Or we don't have to use setters and getters because those are implicitly bound through the constructor. So now I can simply console log product1.name. Let's go ahead and save all. And refresh. You can see that it's returning grapes. And if we say product1.price, we can see that it is returning 99 cents. Okay? And that's how we can initialize values on our class through constructor. Okay, so now let's go ahead and let's explore how we can set up inheritance between classes. Okay? And so we'll have a simple scenario where we're creating a program for our hamburger shop. And the idea is we're selling hamburgers and cheeseburgers, and the price of a hamburger is always going to be $1 less than the price of a cheeseburger. So knowing that, we should only ever have to hard code the price of the hamburger, and then we'll just borrow that value and add $1 to it for cheese, to our cheeseburger class. So to see this in action, let's first start by creating the hamburger class. And we'll have a getPrice method, which is going to return the price of a hamburger. We'll just say it's $5 at this time. Next, let's create our cheeseburger class. And we're going to use the extends keyword, and we're going to target the base class of hamburger. Now from here, we can use the super keyword to access the value from this getPrice method. So I'm going to create another getPrice method on the cheeseburger, which is going to return super dot getPrice invoke, which will return number 5, and I'll say +1, add $1 for cheese. So now we can go ahead and we can create a new cheeseburger. And after we do that, we've already got the method set up, so we can simply console log that value. Okay, so console log cheeseburger1 dot getPrice invoke. Okay, so we save all, and we refresh, Oops. Looks like I might have used the wrong syntax there. Yeah, I added a field that shouldn't have been there. Okay, so we get 6 here. We can see that's correct, right? Because the price of a hamburger is $5 and it adds $1 for cheese. So now our program is set. So as time goes on, we can increase the price of the hamburger and the program will immediately update the price of the cheeseburger based on its inheritance. So I'm just gonna go ahead and test this out. We'll put $8 now for the cheeseburger or hamburger, and we won't update this at all. And as we can see when we refresh, it immediately gives us 9 back, adding that $1 for cheese. Okay. Again, this is referenced as class inheritance. All right, so it's been a pretty good start to things. So let's go ahead and open the floor, and let's see if anyone has any questions at this time. Okay, so let's see here. Your mics are unmuted. If you have any questions, feel free to ask those now.
Actually, I'm pretty good.
Okay, excellent. So if no one has any other questions, then let's go ahead and let's move forward. And next, we're going to talk about the ES6 array methods, okay? And so before ES6, anytime you wanted to iterate through collection of data, you would always have to use a for loop. And then combine it with some other functionality. Well, now we can use array method, which is a function that iterates through a collection of data without the need of a for loop all the time. Okay, so let's go and explore some common array methods. So we got for each, which returns a function for each element in an array. We got map, which returns a function and a new array. And then we got filter, which returns an array of matching objects. Okay, and these are just a couple examples. There's actually a good couple dozen array methods you can use, but obviously some of them are more common than others. So we'll just start with for each here, and we'll set up a simple collection. We'll call it friends, and we'll just say Joe, Jack, Jane, and Jill are our friends. Okay, here we go. Okay, and let's say we want to greet each friend. So to do this, normally, again, we'd have to whip out a for loop, iterate through, and do it that way. But instead, we can use the for each method to return a function which returns a console log for each. So what I'm going to do is I'm going to say friends.forEach, and for each friend in the array, I'm going to go ahead and return a console log, which will print out the string of the friend. Okay, so let's go ahead and save all. And let's go back to our program here, refresh. We can see that it iterates through each item in our collection here and prints out that friend. Okay, and what's great is, it really doesn't care about length, right? We can add more friends here. Oh, actually, we have this one. So let's Jessica, Jerry, and Jim. Okay. So as we save all, we didn't mess with our for each at all, and it just updates, right? It automatically adapts to the size of that particular array at the time. Okay. So again, for each, we have a function return for each element in the array. And in map, it's actually very similar as well. So if we were to switch this out for map, it's going to look like it does pretty much the same thing as for each, except as well as returning a function for each element, it's going to return an all new array altogether. And this is more typical when you're trying to actually render these lists. So we refresh, and we can see that it prints these out, just like we would expect with for each, except this is creating a function and a new array for all the elements. Okay, so now let's go ahead and let's take a look at filter. Okay, and so filter is an array method that allows us to match a given element to an expression, and then it will only return those matching values. Okay, so let's say we have our friends here, and let's say we want to filter out all the friends except Joe. So to do this, we could say friends.filter, and for each friend, we're going to return an expression. And we'll say friend equals Joe. Okay, and if it equals Joe, then it will keep that. But if it doesn't equal Joe, then it will splice out that element. Okay, so now let's go ahead and let's assign this to a variable. Okay, so we'll go ahead and say let filtered friends equals this expression. And we can console log the value of filtered friends. So we save all, and we refresh. We can see that it's only returning Joe now, right? Filtered out all the other names that did not match Joe. And once again, these are known as array methods, right? As you can see, they're just, we just use dot notation to access the method, and it runs accordingly from there. Next, let's talk about ES6 promises. Okay, so a promise represents the eventual result of an asynchronous operation. Okay, so we've got a couple different parts to a promise. We've got the resolve function, which invokes a callback event, the reject function, which terminates promise, and then function, which the callback event will run after the promise resolves. Okay, so to use a promise, we're going to want to make sure it's compatible with all browsers, and not all browsers have support for these yet. So what we're going to have to do is we're going to have to bring in a polyfill for the ES6 promise library. So I'm going to go to cdnjs.com, and as we can see, we got the ES6 promise library, so I'll just copy that. And I'm going to put it right above my other script here. Okay, and that way I can use promises within this app.js script. And so from here, I can go ahead and I can start off by creating a new promise. I'll call it let p equals new promise. And it's going to take in resolve and reject. And remember, those are our functions for the callback and the termination. And then I'm going to go ahead and I'm going to console log I run first. Okay. And then we could do a set timeout. Okay, and we'll set this for 1.5 seconds, at which time we will resolve. Okay, and resolve means it's going to go back to where this was called. So I can use the then callback, at which time I will console log I run second. Okay, so now we're going to see when the browser loads, it's going to create this promise, and it's going to console log this first statement here, and it's going to wait 1.5 seconds. After that is executed, it's going to resolve, run this callback function, at which time we will see this console log printed out. So let's go ahead and save all, and let's refresh our browser here. As you can see, it says I run first, and 1.5 seconds later, it resolves that promise. It says I run second. So as you can see, promises are a really great way we can chain different events, and make sure they execute in the exact asynchronous order we want them to. Okay. So let's go ahead and let's open it for one more time and see if anyone has any last questions today. Okay. So the floor is open. If you have any last questions, feel free to ask them now.
Can you chain multiple then statements on the end of a promise?
If I get your meaning, like, you mean like multiple then? Do you mean like something like this, where I can keep chaining like this?
Yeah.
No, typically what you want to do is you'll just nest a promise inside a promise. So maybe if this was P1, this was my first promise, I would create P2, which should be equal to a new promise. And then you could do something like this. You could say P1 run dot then, and then you could say P2 dot then. And see how they're nested inside of each other now?
Okay.
Yeah. Does that kind of answer your question?
Yeah.
Okay, great. Good one. And does anyone have any other questions? Okay, all right. Well, thank you everyone for stopping by. Have a great rest of your day and happy coding out there.